What we have in this slide is a particular kind of application that is called neural radiance fields, and they are very popular in some contexts. And it is that the network somehow encodes a function. So a function that, for instance, given a 3D object and a projection direction and a location, so it predicts how to project that object or how to generate that object in that direction and position. So it would be a kind of 5D input where you have to give the position and the direction you are interested in, and then the network has to give what is the value of that object in that position and in that location. So that position and that orientation. So this was proposed as a solution of volume rendering, in which you have multiple rays, and then you have to the network to predict what the rendering of that object is, and that is used I don't know, in games or in special effects and these things, and there is a rendering loss. So what is the ground truth, what is the network predicting, and then somehow we measure the difference. Here what is represented here is that if the object is very complex, then sometimes this NERF implementation can require a lot of memory. So there has been some kind of tricks in which the voxels that you are interested in, somehow they are mapped into, mapped means a hashing onto some table, and then the network has to predict for each one of the entries on that table a vector, and this vector is used with some weights, so that there is some interpolation to produce the output coming from the features. So this can be considered as an efficient implementation of this concept of NERF.